Vítejte zpět na konferenci Brno Industry 4.0, konkrétně sekci digitalizace.
Welcome back to Industry 4.0 in the section digitalization section. In order for you to see how the digitalization can help in the company. So you have chosen the right section and the right following of the topics which we will show you shortly. I hope the topics chosen here for digitalization will complement the opening talks if you get back to it from the records. So I recommend you to start the first part of morning conference so that we follow with the topics. We will also show the usability of the ERP systems. In the first discussions, we had an opportunity to hear the representatives of InfoConsulting, and Radovan Antalík is the person who we have here with the presentation, which will start this digitalization block. We will hear this presentation as a strong base for the digitalized production. So let us hear now how ERP falls within digitalization. Help to the company and so I'd like to introduce myself. My name is Radovan Antalík. I work for the company InfoConsulting. This is an international company which is based in Poland, but we are active in the markets in different countries, Central European countries, and will be also opening a branch in the United States. We are also the partner for the implementation of the systems for different companies. As for our customers, so the ERP system is used by a number of companies in the Czech Republic and Slovakia. They are mainly manufacturing companies. They are focused not only on specific segments, but there are a number of companies which focus on engineering, supply of automated production lines, such as the automation company, the production of the furniture, automotive segment, food industries, Pokar, etc. A few words about IFS company. This company is celebrating the 40th anniversary of its establishment. It is one of the oldest companies which manufacture information systems or produce information systems. And this company is showing the statistics. It has extra customers every year, and the sales are almost $1 billion every year. The newest generation of applications called IFS Cloud is the company functional system, which cannot be ranked anyhow as an IAP system because it has overreached the boundaries of normal systems. It is a multi-platform application which is able to operate on any equipment and information and operating system, whether Windows, Android, or other ones. You can use tablets, mobile phones, and different kiosk stations, etc. This is an important element which helps you recognize the application. So it is that this product focuses on total visualization. All the data entered into the system are presented to the user by the visualization tools using the KPI indicators, or KPI indicators, and managers as well as the operational staff see the correct information which they need to see and which they need to work with. This system works on the principle of controlling the processes on the basis of the exceptions, because things which are running well, these are the systems which I don't have to work with, but I have to deal with those which show the problem. Where I have a problem, for example, with employees' attendance or different other issues, so that we can find the cause. When we received this new version, this new generation, so we had to say, and we were quite excited about that, it was an application which is able to control entire life cycle. So it means that this is no longer closed in a box, but this is a system which can control any processes, any areas, starting with an idea. If I should mention an example of a company which has developed and supplied and installs and services different technology, production lines, etc. So the company which knows these processes works with all the processes, development, design, production, and servicing. Now I will show you the phases. These cycles can be supported by the uniform system. I would like to start with the sales or business phase. This is the phase where the sales department or marketing department works with the application, which serves for potential opportunities to be displayed of potential customers. This works with some business opportunities which give you an overview also to the strategic management about how the potential business develops, what pipelines they are, and what is the new opportunity. And it is with different phases, like starting with working on the price offer, on the quotation. Now I'd like to highlight one function where the businesses which want the business opportunities need to prepare a quotation, so they need some basic materials for pricing to the customer. And this is about the estimation of business opportunity, where a person who is aware of the data, who knows how the data looks, doesn't have to work with the Excel to prepare the background documentation for the price offer, but will prepare the calculation within the system based on the data already existing in the system. So if there are some existing bills of materials or existing consultations, existing materials. So there is a system where they can add the data into the estimate in order for them to be able to calculate the offer and the quotation. This sales or business phase, if it is followed by signing the contract, so we will get to the project phase. The IFS project solution is the project solution based on the fact that all the processes connected with the implementation, not only with the production, but also preparatory phases such as the design, structure, TPV, and installation, supply and installation. All this is controlled within the project. There is a possibility to follow the project activities, and there is an opportunity to create some forecasts, project costs, project revenues. So there is always some information available of the current status of the project. And this it looks like this. The project management looks like this. We have some project activities which have their own deadlines, the estimated hours, and within the project management there is an allocation of the resources. There are some specific designers and one designer can work on multiple projects. You can find out what designer is working on them, which projects he or she is working on, etc. I started with the designers, and now I will talk about the next phase in the life cycle, which is the development. At the beginning, when we start the project, we need to prepare the production documentation. So new drawings have to be made, new models have to be made, and in this process, basically the system integrates all this construction data. The life cycle of the product is based on the fact that there are three types of the structures, three types of bill of material. It is EBOM, MBOM, and SBOM. And the bill of material, they are the data which are then supported by the technologies, and then the production documentation follows according to which the production starts. In the production process, changes occur because the customers may require change, the designers may require change. So in this moment, the actual bill of materials material is used, and the serial numbers are followed, the batch numbers, and you will see how the production line was manufactured for a technical equipment of some kind. The bill of material, which was established, then the structure is reflected in the service, and this is the service bill of material, and this is for the equipment to be able to be serviced. This is, you can see that there was a serial number, and everything can be found in the system.
Until the equipment is out of service and decommissioned. So, in order to make a comprehensive control of this process, IFS has introduced a methodology called project deliverables. So, the principle of project deliverables is the bill of material, which is the order where you upload the data. So the project deliverable is related to a project plan, what time, what branch, what section of the you need to process. On the other hand, design transfers data to the system. so that based on the data you can start the production. The principle is that you don't need to have the whole bills of material ready, not all the layers, but gradually you can keep adding the parts in the project deliverable, those that have been configured, and this project deliverable is then how you can start procuring and start producing based on the design documentation, and so that you can plan the deliveries to the customers, some shipments that need to be delivered on site, and of course some work orders for the equipment to be commissioned at the customer site to go through the factory acceptance tests and all other things until it's been put into use. The greatest benefit is that the user has one window where he can see the entire project tree, so all the components that are coming in the order, so he can see whether the documentation is ready, and it's like a supporting document for planning over time and helping to plan the costs as well. So once the production documentation is in place, or at least some of it, we can proceed to the implementation stage. So in the next part, I'm going to talk more about the production, because of course you have some procurement process, price quotations, and the entire logistics that goes without saying. But as regards the production part, the production stage, if you look historically, and we've heard that, we started with the digitalization gradually. So the company started getting some billing programs so that they could pay the VAT. Then they started adding some other features like warehousing, purchasing, and so on. So the L4 level is about some traditional ERP systems. And then we have level 3, and we will talk about it later. These are specific software systems for payroll, production planning, and so on. What we bring in the new generation as part of a single system, you have both level 3 and level 4 together. So it's like a solution that is called a connected factory, and this is based on 4 basic areas. The first one is, of course, detailed scheduling and planning of the production operations. Then we have real-time monitoring of the production process and related production monitoring, and then with the incoming data from production, the system keeps evaluating the data and brings supporting data for decision making and for improving the efficiency of the production process. So the solution itself is, as I've said, it's part of a single system. So the user in the production, they use a single system. The advantage is that the data is consistent. So it's not that you have any complicated business topics, no interfaces. So this system can also integrate some third-party solutions. So this is an open system enabling cooperation with other softwares. Another benefit is the cost of the solution and the cost of maintaining the solution, because this you have a single vendor, single provider that also provides the servicing. So you only communicate in one direction. So if you look at the details of the components of the LMS system in IFS, of course, what is very important layer is the detailed capacity planning, where the system keeps evaluating and rescheduling and changing the production plan based on the accessibility of materials, the machine availability, manpower availability, or tools availability that are needed for the operations. And as a result of this detailed planning, you get a real-time operation line for each production workplace, so the data is immediately accessible for the workshop management, which is a tool which is really running in the workshops where the foremen really work with the operation line, with the queues, and they manage the system based on the data that are collected on the shop floor. And of course, the data can be collected by the operators if it's some human work. And it's also very important is once you have some production facilities integrated in the system, the data flows to the equipment to know what programs should be used in CNC and machines and so on. And on the other hand, you get information from the machinery about the production, and you also get information about the diagnostics of the equipment, so that the maintenance staff also has information about the condition of the equipment. So the operators can use a workshop panel. This can also be used on any device, mobile phones, tablets, and on the huge touch screens that are located on the shop floor. As regards data collection from the production equipment, the greatest benefit of the monitoring is OG. So this is when you evaluate the availability of the production machinery, meaning how long the equipment was in operation, what was the downtime. And this is, of course, related to production, where the system evaluates the production, how much has been manufactured, the losses, and the last indicator is the quality. So this shows how many produced pieces were good, the number of faulty pieces. Then you get a calculation, and the production managers get a detailed analysis of the condition of the equipment. Another important component which starts being implemented at the stage of development is the quality control. And this is based on FMEA, where you can already specify some potential errors, defects in the processes, and based on that you can identify the causes, and you can take some preventive steps. So this basically shows what should be checked, and the process control plans give you the details of what should be checked. So the result of this check at the input or output is some statistical check of the process in real time. So you get real-time specifications that graphically show you the condition of the components that are used in the production and the fluctuation of the quality and deliveries from the suppliers over some period of time. And the last important part of the IFS solution is maintenance. Again, this also uses data coming in from the production machinery. So the maintenance has its own catalog of spare parts, set of equipment that is being maintained, and you get an overview of each piece of equipment and the parameters that you need for the diagnostics, because based on the parameters you can carry out preventive maintenance, which means that if some piece of equipment gets some value change, then you have to interfere because there could be some damage caused. What is also important is to have an overview of alerts or alarms exceptions that deviate from the normal situation. And what is also interesting is that the system can also use machine learning elements and AI elements to make a prediction of these values in the future. So for the maintenance staff, it means that they can predict what could happen in the near future if some important values change. So the last stage, so we have the produced and delivered equipment. So then you have the servicing stage. The servicing module under IFS is a comprehensive system managing all services that are related to your own equipment servicing, or it's also used for by service organizations that have service level agreements. They take care of halls, equipment, buildings, trams, whatever. So this service module works in a very simple way. So at the beginning, you have a request for service. This is processed in call centers where these requirements are recorded. Then it's sent to the control room where the staff processes the requests and they try to allocate it to the service technicians. You then develop certain plans how the technicians should implement the service tasks. If the service goes to the implementation stage, then the service technicians, of course, uses the mobile equipment and can find all the allocated tasks. He can see the material to be taken from the warehouse, then he logs in the task. Then he comes to the customer confirming that he's on site, then carries out the service, then reports the consumption of material, fuel, whatever, and the time. And as a result, you have all the data in the system for billing. In the service module, we also use advanced planning. And this is the advanced planning, not the advanced planning of production operations, but this is about servicing and optimized routing for the service technicians' journeys, so that the servicing is efficient. So here IFS can be integrated to GIS, to the map data, so we know where the devices are located, the accurate address and the location. To close, what is an interesting integration in the service management, this is a solution, a third-party solution, which is called remote assistance. The way it works is once you have a service technicians coming on site and he needs to be helped with something, then he can have a conference call using his mobile device, and the technician who is seated in the office then navigates the service technician through the video chat, telling him what should be fixed, what should be pushed, and so on.
All this communication and video records are then kept in our system and are available also for other technicians, for them to be able to get ready for some service interventions. One simple sentence in the end, which is not artificial intelligence, but what I want to say is a slogan which we use also for our customers, and it is that even complex things can be done simply. It is because of the fact that the system which is here now is the system which is manufactured one by one manufacturer, supplied by one supplier, and covers all the areas which the company needs. Thank you for your attention. Thank you for this presentation, and if you have any questions, please ask the speaker to answer them privately, because we have such a stressed agenda that we can't give you time for answering questions here. We will proceed to the next topic, which is again ERP system. The ERP plus superstructure in the AP systems as a strong couple at the time of changes. Michal Hégr from Minerva, the Czech Republic, is going to speak about them, and we will hear the relevant presentation now. Good afternoon, ladies and gentlemen. I work for Minerva, the Czech Republic Information Systems. Here you can see the basic information about our company. We have worked over 30 years as a system integrator, where the main ERP system which we supply is the information system QAD, which covers standard area of production companies. We have over 150 customers, and the system is designed in such a way so as to cover the segments that you can see here. These are the logos of our customers, which we as our company did. The ERP system of QAD, so the company was set up in 1979. It's been used by over 7,000 manufacturing plants. Here you can see some information, some more information about the company. We use the ERP system, and we connect with it the advanced planning system by Siemens. Using Siemens products, which are developed. You know that Siemens pushes the industry 4.0, so it means digitalization. One of their products is whatever I'm going to show you here today as well. So the planning in the companies is an important process, which, however, is dependent on other departments as well. But this process is crucial for deciding whether you supply in time what the customer requires. As my colleague said, the main thing is to supply the customer with what the customer desires. It's important to have the planning process covered by some tools. We use the combination of different systems of ERP and Siemens APS. We use three types of plans and planning. Number one is the short-term planning, and other people can have the medium-term plan. where you can see the projects, what the customers will desire, at what time, because you have to allocate the capacity for this. We also use strategic plans. By this we cover the basic plans, which is the planning and decision making. The planning answers our questions about what we should produce, where should be producing it, how, what resources are required, etc. This is what we cover by the standard MRP system, by the QAD company, and the decision making about how best to produce, how best to get operations together. So it is here. I will show you that what has been said here does not always have to be connected to the ERP systems. It can be also independent. If we take standard planning in the ERP system, so it depends. It is dependent on many other departments. So what do the customers want from us? We need to have well-done structures, optimization parameters, stock or the material in progress, production in progress, and any department supplies bad data into the systems will cause the planning to be non-operational. So if the ERP system plans here, so you'll change to the second most serious, most frequently used information system, which is Excel. Excel is widely connected, and it substitutes the inconsistency of the data. It is always desired to enter the good data into the system in time. If you omit one of these requirements, so it will be a problem. If we look at the difference between the MRP planning and APS planning. So if you receive any sales order for your equipment, the system allocates the capacity as a standard. So this is some setting up time. This is the production capacity, and as we have the ERP system, which is allocated and compiled for a specific machine and equipment. If the same is done in the APS, so it means that you can say how the system should behave. If I have the same here. So I have the requirement. So put it in the following order. First I want green, then blue, then red. So minimize the controlling time. And I have there that it will not be illogical to compile the operation as they are. If the system doesn't have this, so it is the work of the foreman, but it is restricted in some ways as well. So if I plan using these systems, so I acquire a certain capacity. The planners don't have an easy life, because if you take a machine and 3 operations, so within 3 operations there are 6 possibilities. So it is blue, green, red, blue, red, green, etc. At the moment when you need 5 operations, so there you will have 120 opportunities, and this is pure mathematics. If you use 8 operations, so the possibilities, there are 40,000 possibilities. You can use Excel, as I've mentioned, and the product which we implement on the ERP system. In order for you to be able to call it APS, so in this case it needs to fulfill some criteria. If you look at the overview of the APS system in the market, so they are quite a few of them, but not all of them comply with the requirements of the APS systems. If we look at the equipment, and if I want to plan, so the system as a standard will give you an operation, the first operation, because there are some following operations which are subject to the first operations. Then it is followed by the third operations, and there is a special order of the operations on the equipment. It also looks at the stock and of the material or semi-finished products that you had produced in the past. It also looks at the purchasing orders, and in this way it just gathers individual operations so that you can achieve the result of delivering the right product to the right customer at the right time. At the engineering level, you have a lot of bills of material. Sometimes there is installation, assembly, and this may not include the planning across all the steps. We always try to do it within 1 year. I mean now the planning, any drawbacks in any part. So during the replanning, the system behaves in certain way. This is another functionality. I will put the examples of each customer, and you will see what the system should be able to do. It should be used for planning finite capacities. We can use it for cooperation and its purposes. It should be able to plan the secondary purposes. You may be missing something. Most often it is that you lack people, professions, but we also had to deal with the shortage or non-existence of the crane or some tools or anything that can prevent you from doing the work to be done. There are some, the supplier should have experience with the supplies when we spoke about TDK in the morning, so they found the solution as they wanted, and then they were trying to find somebody who would implement it. We had employed a lot of software then, so we won the tender. What can I help you with? Here are some advantages. I believe you know the Corrado company. It is the biggest manufacturer of radiators in Central Europe. It is based in Česká Třebová. It uses our ERP system, and we implemented APS there. Why did they want it? This is the list why. They were always used to manufacturing relatively narrow range of products, but the time has changed, and now they are changing into the philosophy of producing what the customer requires, so that they didn't maintain what's some things in the stock. So the range is expanding, and this was one of the reasons they needed to solve the issues which they felt then.
So these are the targets they have had. They wanted to reduce the requirements for the delivery to the customers. They wanted to reduce the administrative load for the planning. They wanted to reduce the work in progress. They wanted to produce in time for the customers rather than keeping it in warehouses. And this is a description of a condition. Perhaps I should say why they took the solution from us, because of course we have been active there for over 15 years, and we are like the system integrators for them. And as a result, they deployed APS from our company. So these are the benefits. So reduction of and copying of data. So they only use spreadsheets, so a more accurate and faster response to the customer's requirements, easy rescheduling, because if we use the operative planning, this is like everyday replanning. So it's not something you do every 5 minutes. You don't want to change the plans for the foreman. But in principle, the rescheduling takes place every day unless there is some collision, unless you have a bottleneck. You can replan it anytime, but as a standard, it's a daily rescheduling. Then it shows you what delays some specific orders. Of course, customer satisfaction in terms of the deliveries, clear interfaces. So if you look at the specific purchase order, it shows you what orders and purchase orders cover this production order. So the supplier can also see our data. So during the implementation, we managed to optimize selected follow-up processes and analysis and so on. So once we introduce APS in a company, before that we make an analysis and we also look at the related processes. Very often there is a problem that in order for the system to plan the manufacturing for a specific day, you need to get the material in stock at least 1 day beforehand or on the same day. And what sometimes happens is that the supply department doesn't change the dates of delivery, and then you get the material on the next day. So we have reports for this when we are dealing with that. So it's what the customers require. So we want to make sure that you don't go to the stock and it's not there. So another example of our customer that uses it is Fermat. It's a Brno-based company. This is where they are also using our APS system. This is where we go to a company and we introduce the APS system. In 90% of cases, you are replacing an old system. So this was a company that 10 years ago had no system in place. At that time, they were expanding a lot, and in fact, they only used Excel spreadsheets, so this was quite a strange situation, but they managed to find their way quite quickly. So when we introduced the system, they found many things in stock they didn't know they had at that time. And what was interesting, that they told me that it was basically the price of the system that they paid, what they had in stock. So as regards the reasons of deploying the system, again, they wanted to streamline the planning process. They wanted to know the accurate deadlines for the work orders and purchase orders. They wanted to get detailed scheduling, increase the discipline, implement and optimize warehousing. They wanted to increase the production of the machinery with the minimum cost increase. So the benefits, well, as I've said, as a standard, the APS system replaces or basically introduces 2 types of plans. It's the workshop planning and then it's the midterm planning. The midterm planning uses standard data from the ERP system, and it can be rolled out quite quickly. So you also get quite quick benefits. So you can see the first outputs in 2 months' time, and it was the midterm plan. If we look at the decision making, it's about the algorithms for the specific groups of machines, how it should be put together. So it's like a Lego construction kit. When you take all the orders and operations and you need to retro it to avoid all kinds of gaps, so that it just you have follow-up in all the operations. So I just have to be mindful of the time, so I should move on. So today in the morning we had a presentation from the executive director of Baumüller. And this is one of the things that help them in terms of digitalization and streamlining the plan. So you could see that the reasons were to transfer the manual planning into automatic planning using a software, getting data to be processed, and so on. So we have reduced the. So you could see the reduction of 25 machining shops, 30%. And another option is to simulate the plans. You can release the capacities, and there is no time. You don't need to deal with the operating matters.
So here are our customers. There is Siemens. This is the reason, because it is Siemens product. So Siemens does not only sell it, but it also produces in their and deploys it in their own companies. And we did it, for example, in Frenstadt, in Brod, and in Brno. In Brno, it was the production of turbines, which is a totally different production. It is almost the project production. So they produce something, they manufacture something. They have 50 manufacturing companies in Liptovský Mikuláš. We implemented this APS solution, which I spoke about. Now the Caterpillar is being completed in Holland. What could be interesting here in terms of it is, for example, in Prešov, the manufacturer of gears. They have a lot of patents, and it is precision production. We measure several parameters there, because if they assemble this and run the gear, and it heats up to a certain temperature, they just have to stop it and adjust it. They never make scrap, or produce scrap, but they always have to find the right parameters, and they need the or Solodor Sušice. It is the production of doors and door frames. When I go to the company, so you go there in a couple of years, and the production looks totally different. And they had, for example, 30 people. Now they have the machine for 30 million, but they have 3 operators. So they are, instead of 30 people, they are 3 people. And of course, the machine is the robot which they operate. These are our customers. If you are interested in a specific customer, you can ask me. Otherwise, we connect the system with the ERP system by UAD, but it is applicable to any other system. Siemens has it independent, so we connected it to SAP, to Helios, Scala, Epicor, Movex, or other ones. If you have any questions, ask. My presentation in principle has finished. So if you want, I will be here. Thank you for the topic. Ideally, please take this opportunity. We are here to share experience. You have heard a lot, so if you want any questions, so please ask the gentleman at the backstage. Now we are going to talk about Baumüller in Brno, which it was part of the discussion panel in digitizing the Act-in company was helping, and because we have Lubomír Sláma and Milan Šamšula, the representative of the company, so we can look at Baumüller Brno into more detail. We can look at how the digitization of the production and maintenance took place. Good afternoon, ladies and gentlemen. I am Lubomír Sláva. I am a managing director of the Act-in company. I'm glad to have here Mr. Šamšula from Baumüller. Mr. Šamšula is the head of the mechanical production. Our afternoon presentation should follow up the morning presentation Mr. Zubr from Baumüller had in the morning, which looked at this from the top management point of view. We look at it from the point of view of the supplier as the creator of the solution and Mr. Šamšula as the everyday user of the system. From the point of view of this, I won't be speaking about the specific solution which Mr. Šamšula will be speaking about from Baumüller, but I will say something about the conceptual approach of our company from this digitization. And then we will have the story of implementation and digitizing of Baumüller company. When I talk about the stories, I'm glad that we are at today's conference because our story started here in 2019 when we met with Baumüller here. And we spoke about what our company did, that it had an implementation center here in Brno, that they had some experience, ladies and gentlemen, who have a deep knowledge about information systems and about the fact that in addition to being able to implement it in the Czech Republic, that we are also able to implement it in corporations across Europe, and our colleagues go there. And in addition to the implementation in Europe, we are also able to implement the system in the United States, Mexico, China, or Saudi Arabia. So we are a global supplier of production information systems. Most of our customers are in the automotive. They could be subcontractors, suppliers of car parts, or sub-suppliers in the aviation industry or in many areas. What was important for Baumüller company was also that we are able to also deploy the companies, the system into other companies of this mother, of this parent company. So we have here the machining, there is the foundry industry or other areas which we are active in, such as plastic production, medicine production, which has high demands for the cleanliness, for example, printers or other industries. What's important is that within MES we collect data from different assembly lines, automatic lines, manual or assembly lines, or fully robotized workplaces. MES is integrated with different types of technology in terms of the collection of the data and the final recording of the data and the checking of the technology. Interface is also important for the system. This was confirmed in the Baumüller company when we asked how the operators can work with the interface of the system. So also in our system it is an important part. In addition to the machinery which most of MES systems deal with, there are also some which deal with the manual assembly workplaces. MES have as a concept is in the middle of this between the PLC and sensory and the business management. This is the area which they are only approaching the digital transformations at the moment. They are accompanied by many forms, papers, and Excel spreadsheets. And here, Act-in MES has an integrated solution. In this case, it is a three-tier system. Above that, it is the information system, and the middle part is the MES system. If we look at the illustration of the production process in the engineering company, so the MES system comes after the planning, whether it has a module of production planning or whether it reads information from the ALP system. So we have the production logistics, traceability, the tool administration, the control of assemblies, the packaging, and always it is in connection with the ERP system. We also deal with the directing of the tools, monitoring the service life, the tools, the dies, measuring equipment, instrumentation, material and semi-finished products, traceability and logistics, manipulation, handling equipment, and the connection to the warehouse equipment. Then we have the computers, computer networks, communication modules with machines, some other hardware parts which always are dealt with within the complex approach to digitization. The result of the digital transformation, there is the opposite of inefficient island solutions, where the MES system brings some integration into the company within the systems, within the parts which the customer has already used. Everything is driven by the central data collection, which is a central motor for the digitization of the production. This was the approach of the supplier about the comprehensive approach, and now I'd like to pass the floor to Mr. Šamšula to tell us how they use the system, how they approach the use of the system, and etc. A short introduction of the Baumüller company, who was not here in the morning. Baumüller is the manufacturer of the electric drive, including the powertrains. It was set up in 1930 by the Baumüller company. At the moment, it has about 2,000 employees. In the Czech Republic, 402. Other production places is Germany, Czech Republic, Slovenia, and China. And the global service and support has about 40 branches, and the annual turnover is about 15 million euro. This is where we are located worldwide. We focus on Europe and China. If we look at where we supply, so we are an order-made company. We supply textile industry, printing industry, and other ones.
If you look at digitalization globally, what led us to digitalization? What was the driver? Well, in fact, we wanted to meet the visions of the company. We wanted to increase the production capacities. We wanted to make better use of the existing production capacities. We wanted to ensure the increased productivity of the manpower, and we wanted to get rid of paper form of the production control, production management. So, of course, we need to reduce the downtime. We want to improve the quality standards, planning, and we also wanted to increase the efficiency of maintenance. So the main criteria. So, in fact, we had two of them. We wanted a company that could provide a comprehensive solution. We didn't want to focus primarily on production. We wanted to cover the technologies, quality, maintenance, which was provided by Act-in, and a company that has experience with their implementation in production. We wanted to be able to read data from the system, ERP system, and the planning system pre-actor, which was presented a while ago. And in order to be able to collect data, reports, analysis, because this is the bottom line of digitalization, to be able to get the information from the systems. Another thing was the speed of implementation and support to be provided by the vendor. So the main milestones of the project, so we can start here. So we had a short meeting at the conference in 2019, then presentation in the company, presentation by Act-in. Then we work on the terms of reference. Our expectations from Act-in, the price quotation, a reference trip. We went to Black & Decker. I will show you later what we saw there. Pilot project. This is where we used 3 machines, so I will show you exactly what we implemented. Evaluation of the pilot project and implementation of the main project, which is still up and running. So this was the reference trip to Black & Decker in Ústí nad Labem. We were quite impressed. We witnessed the quite variable workplaces, so we could see some molding presses, some tool machining centers, and what was quite important to see was maintenance, because at that time we only used some spreadsheets. It wasn't efficient at all. So this was another milestone and driver why we decided to go for the stage of implementation. So if you look at the pilot project, we basically applied 4 main applications. Field client. This is a client who is at the workplace, at the screen. Then maintenance, which was a comprehensive solution to the maintenance. Then performance analyzer. And in fact, this is an application where we analyze all the data concerning the workplaces and the machines. And shop floor control, where we deal with the quality instructions and so on. So this is an example of the main screen for the operators, where we are able to see the orders. We can see what is being done, who is logged in. So this is a comprehensive solution where the operator can communicate with us, with the technologies, with the manager, with the maintenance, and so on. Then we have a definition of the reasons for losses. So this is one of the options of the field client. So the way it works is that we have a definition of saying that if the downtime is longer than 10 minutes, then the operators need to give us the reason why it has happened. So I will show you some more details later. Then instructions, which is all controlled documentation, which is all in digital form. We have no files with paper. It's all digital. And the quality department that is in charge of that this is what makes their work a lot easier. And we can always call up the maintenance staff, which is again related to the maintenance project, as I will show you later. So this is just an example when we implemented the pilot project. So if you look at this, the red lines don't really say anything, but this is one, I think it's a morning or a night shift in the company when we implemented the Act-in system. I wanted to be smart about it, so the way I did it was that first I connected it to the system. It was up and running for a month so that we could collect some data before entering the panels when the operators already use the field client. So if you look what happened later, so this is about 3-4 months after the deployment. So the green lines, this is the production, and then at the bottom there are no red charts, and this shows production where there is all the downtime is eliminated. So the pilot project, then I will talk about all the applications in detail. So as part of the pilot project, we had maintenance, which was a communication across the company and maintenance. So we implemented a website interface, so anyone from the company is able to send a requirement, and then it's sent to the active maintenance system, where the head of maintenance can comfortably allocate the tasks to the workers in a mobile application. So each maintenance man has a mobile phone with an application, and if there is a requirement to fix a bulb, then the head of maintenance allocates the task to the worker. So I think that this is quite a good tool, and we were also able to, as I said, detect some downtime. We managed to eliminate someone walking down the corridor. He tells the maintenance, he urges him to do something about it every week, and a month later he doesn't even know he asked for something. So all the requirements are now listed in the system. You can make all kinds of evaluation. You can look at the costs as well, and you can basically monitor the entire task. As regards another feature, maintenance, now currently we can have all data in one spot, which is great. We can have general data about the workplace, about the machine. We can have all kinds of calibrations, the date of acquisition of the machine, all the way down to documentation. So now we can record all the inspection reports, all documentation related to the workplace or the machine, invoices, and so on. So the last thing there is communication with the machine. So the operator has a panel. If there is any issue, he can push 2 buttons and he can call up the maintenance staff. It works very well because we have a definition that the machine is in downtime. So if there is a serious failure and the machine is not available, then it's an instruction for the maintenance man to react. If we look at the main stage, because this was just the implementation of 3 machines plus maintenance, so once we made the evaluation, we decided to implement it for the machining centers, and the efficiency went up by about 15% just by implementing some communication panel, efficient management of the instructions, maintenance, and the downtime. So we decided to roll it out to all the machining room, which is about 30 pieces of machinery. So we use software and maintenance, performance analyzer, shop floor control, field client, and plant view modules. So how it's connected?
We have one central SQL database. It is the brain or memory where we have the Infor connected. Infor is RP. Pre-Act is the planning system. Then there is Acting. Then we have Power B where we use the data to visualize this and this is a short overview of how what the variety is of our machines. So you can see that we have a great range of machines. Biglia has HOC, grinders, DMG, gamma machines. So the connection was not very easy. We have so many control systems. And we also have the manual workplaces connected. So they are not control systems, but it is done by the panels, through the panels. And here you can see the control systems which are able to be connected is numeric by Siemens, Celos, Haas, and of 2 versions. This is just for your idea. These are traditional equipment like DMG, Gamma R, HOC, Toyota, or the grinder. We also have some older machines, radial, drill machine, or the lathe. And depends how the Act-in MEL can connect. It is quite amazing. Mr. Zuber mentioned this in the morning. This is tomb impregnation equipment. It is quite a difficult equipment with a lot of data and a lot of elements. How the machine works and operates. We have a lot of data here, and this was caused. This also enabled us to increase the production by 20%. This is the heating furnace with the tests, and we are able to use such equipment. In terms of the application that we use, number one, it is the performance analyzer. This is the application when we read data. It is online. Here we can see all defined things and tasks that we need. If I take it from the top, we see the production orders, what the machine produces at the certain time. Then we see short and long idle time. We have it defined to short and long. If it's like they are about 7 minutes, the difference between them, if it is longer than 7 minutes, we ask employees to justify why it was idle. There are some technology issues, change of the measurement units, etc. Then we are able to read the correction of the revolutions, shifts of the speeds and programs. It is also interesting because we've seen a traditional example of the fact that when there is no foreman, so all corrections went to 20% because in the evening it was necessary to have a rest. So this was eliminated, and we are able to read even more detailed data, and the company Act-in MES is able to give us some custom reports, which is very important, particularly with respect to this tomb impregnation, because we needed a lot of information, and this is different for each machine. Just for your idea, we have the reports. I usually use 2 types. One is for 1 day. We are able to look at the technology what was there for one shift. Here you can see that it was 10 minutes, like replacement of the parts took a certain time, and the technologies then can do some corrections. Down here we can see a weekly report where we deal with OEE, which is the speed, availability and quality, and we are able to work with the data and use them, for example, for savings. The next module is the shop floor control, and we use this application to control quality. We see here that we are able to include all digital forms of different instructions, control documentation, photographs, and drawings. The main task of quality is to inspect, so we have the inspection plans here with regard to the articles or issued parts. It is then transcribed into the screen where the employees fill in the values, and we are able to work with the data. And last but not least, we have a new development where we use digital units for measuring, for confirmation and recording into the database. Another thing which is quite new is that we improved the module in terms of planning for foremen. When the planning takes place, we plan every day and always in the morning if there is a priority or the plan can be modified, so the foreman can go to shop floor to go to the control or inspection, set up the order according to the priorities, and it is immediately transcribed into the digital form and to the panel. The next excellent thing is Andon, which is the field client function, where we are able to communicate across the whole company, where the employee who needs to speak to the team leader will set up a task, which is then connected with email, and we have now the logistics set up, we have the team leader set up, we have the technology and the quality set up. So anything that the employee needs to deal with will call whoever he needs. There are two more types of screens. We use about 3 at the moment. When we have like 3 workplaces, we don't need 3 monitors. We can do it in such a way that they just switch over. We also use the so-called paletovka, where they have a double production running in parallel, and within Act-in it can be downloaded, and we can see the analysis of two projects. We also have autonomous maintenance, and this ensures us the better OEE or the availability of the equipment. One module is for the person to, if they have a problem, so they call the maintenance, they record the detail. The maintenance person already knows what the issue is, and another thing which we use, the autonomous maintenance. At the moment we have the daily cleaning or service of the machine. So there is a history, we can see the recordings, and if the foreman sees that not everything is in order, so he can see whether he can make some other measures. Everything is transcribed into the database. We can see all the tasks here. We can see an extreme quantity of the data from somebody who issued the requirement and who did it and who. We will now proceed to maintenance. We are not using it only for maintaining, but we also have other modules that I'd like to show you. This is the controlling of the whole company using the application. Another thing which we use is the documentation, which can be found in Act-in. It is within the maintenance. They see everything in the mobile phone, so they don't have to bring any files with them. So if we have a Czech plant within the half-year revision, so we have a list of points the maintenance person has to cover, and we are able to work with it and, for example, whether it should be done in different ways. It is connected with the planning system, and the maintenance person can plan the entire year. And by this, it is possible to control the efficiency of the persons.
Další věc, kterou využíváme v rámci maintenance, tak je určitě dokumentace a vůbec správa majetku.
So this is the documentation and the asset management within maintenance. If we have a failure of the machine, so we are able to record how much it cost. We include the time. We are able to control the costs of the entire entity. And then we have a very good, clear summary of the information about the object, and we see also how expensive the machine is and whether we should replace it or not. The next thing that we use, because we liked the connection, like the maintenance, so we started using it within the jigs. So we have about 5,500 jigs and different measuring devices. We like the planning of the revisions of the jigs and the metrology, so we don't have to control it with the databases, and we use all the possibilities in terms of the information, jigs, documents, etc. I have also here the documentation, some pictures and drawings, etc. The main milestones. The last possibility that we use is the online visualization and reporting. We can see how the machines are currently used, whether they are running or not, what projects they are working on. We also use the Power BI reporting system, which is used to the database. We use the data from it. We have the sets every day. Every day we have the meetings of the top management of the entire production. We have the planning, and we deal with the current issues using the visualization. To summarize it, the entire project has been implemented within the machining shop. We would like to connect more production. There will be another 100 new production workplaces. We plan to digitize quality, all steps, and they will using Act-in, and also the digitization of logistics. It will be also helpful. Thank you, Mr. Šamšula, for this excellent story and presentation, the story of the user who was at the beginning of the story and who is part of the story. And as he said, so hopefully he will be part of the story in the future. And he showed us what data and what functionalities of the systems he is using as the practitioner from the production. And I think this presentation was a nice follow-up of the morning presentation of Mr. Zubr, who looked at it from the point of view of the top management and controlling and managing the company. That's all from me. Thank you for your attention. If you have any questions, we'll be happy to answer them. You can see us at our stand. So anything you would like to tell us, we will answer. Good afternoon.
Thank you for your presentation. We see that the topic of digitalization, it's something where we can always come up with some new information throughout the day. And digitalization is also going to be the topic of the next presentation. I mentioned some acronyms, RPS and MES. MES is going to be the subject of the presentation. PHARIS, MES PHARIS, which should be a competitive advantage at the time of crisis. And we are going to talk to Mr. Tomáš Hradský, and I'm quite sure he will try to convince you in his presentation. Good afternoon, my name is Tomáš Hradský. I would like to introduce PHARIS to you, which is a tool to manage crisis. I don't like the word crisis, so we should talk about crisis as about an opportunity. So let's see how we can face the situation together with PHARIS, what we want to prevent from. So first, something about the company. PHARIS, MES PHARIS. Last year, there were many changes made, and they will be completed on the 1st of March. I've been the managing director of the company starting from the 1st of May 2020, and PHARIS section that develops this MES system for about 15 years is going to be a spin-off of the company, and it will follow its own path with its main product, MES PHARIS. So, of course, there is a number of other changes taking place. Until now, our company has dealt with, has mainly concentrated on large production companies, mainly from automotive segment. And we are well known with our range of portfolios, and we were not a good product for SMEs. Due to the large implementations, due to the price. So now we have completed the product transformation, and it comes in 3 alternatives: Express, Standard, and Ultimate. And now, during this year, we want to take out our integrated planning, production planning, and we are going to have a special PHARIS APS cloud service. When I speak about cloud, the product is also offered as a cloud solution so that it can easily be implemented by SMEs. To make it even more simple, we have several types of ways to get the product to the customers. So it can be leased to be tested, or in form of long-term cooperation in the form of software as a service. We can also offer pilot projects, feasibility studies, and we expand the partnership network, so that we don't even have implementation partners in the neighboring countries, but we also want to have business partners that we want to go with to see the end users and offer PHARIS as a solution in order to optimize production. So I'm quite proud of saying that last year we managed to finalize innovations, things that we have talked about all day. We have digital twins. We also have a surveillance center, which may sound quite boring until you know that what is behind is like machine learning, almost artificial intelligence, evaluation of data coming from the machine, prevention from future problems, and so on. We have a brand new algorithm, so apart the scheduler that are used by our clients, we are now testing production rescheduling with our main customer in Denmark. So we are testing a new APS system of making schedules, production schedules and plans. And we try to keep up with the times, so we focus on software optimization, lean production, optimized processes. So what is MES? We have heard about that. What is our MES? It's a very robust solution that can address the functionalities, and it can really go in depth. And it's an individual comprehensive solution in the broadest possible form. So you can set up the processes based on the customer's requirements. What kind of segments? Well, all discrete production, not only automotive, pharmaceuticals, plastic production that we specialized in. So generally speaking, all kinds of discrete production, including assembly. So what is it good for? Why do I want it? So I want to optimize the production. I don't want to have papers around the shop floor. I want to save time and efforts. I want to save manpower. I want to have a clear view what's happening on the shop floor. I want to optimize the processes and streamline them. So the advantages of our solution, as I have indicated, we have 3 product variants. We can offer a very simple version that covers the main needs that I have and enables growth with the product. I'm not saying that there are no boundaries, but I can transfer between the variants that I've presented, and I can have a solution that is specific and a solution that brings a number of user scenarios. So if I need some basic connection with the machine, some visualizations on screens, data evaluation, and some basic user scenarios, I can do it. So this is PHARIS Express version, and over time I can start having a more comprehensive solution, and the door is not closed. If 2-3 years later my customer asks for just in sequence feature, I can just make it operable in PHARIS. So these are the advantages: comprehensibility and flexibility, related services, 15 years of experience, consultants both in the field of MES and production management, specialists on lean production. So the added value is that we can propose systematic solutions to correspond to the needs of the customers, and we can expand the system in time. So this is just shortly, this is a modular solution, so I can choose the setup of the system, what it's made of, what is available, the restrictions. The essential piece of information is that we have dozens of user scenarios. Each version supports some of them, and I can pick and choose which scenarios I'm using and at what time. So the PHARIS implementation doesn't have to be 1 year of work. It may be much shorter. I choose some scenarios. I put it into operation at the level of data collection and evaluation, and then I can add on more and more features. Maybe I don't even know what I'm going to need in 2 years' time. So individual approach consultants, our partnerships. The way it works is that we have continuous contacts with the customers. We discuss current needs with the customers and development. So now I would like to ask my colleague to take over, so we don't only talk about facts, but we would like to give you the stories of our two customers, how they started using PHARIS and how they grew with PHARIS. So let me introduce myself. My name is Michal Uner. I've been working in PHARIS starting from the 1st March for less than a year. Before that, I spent 25 years working in production plants as the head of production manager, where I was responsible for the production itself and for engineering, quality, planning, internal logistics. So as regards MES system, this is something that is close to my heart. I know that I cannot improve what I don't measure. That's what we've heard before. So I need to measure it. I need to have 100% correct measurements, valid measurements. And if I measure all the data, then based on that, I can make a usable analysis. I can take corrective measures, and I can also validate in real time that the measures are working well. So I would like to share with you two examples from our group of satisfied customers. One of them is ATEK. They deal in the field of automotive. Right now they have almost 500 employees. It's mainly a tool shop, logistics centers, press rooms. This is a Czech company. During the first crisis in 2009 and 10, they used the opportunity and they won interesting projects as regards the production portfolio and the volume, and they realized that they cannot really use the old method of paper, pen, and spreadsheets, that this is definitely not the way to go. That's why in 2013 we were approached by the representatives of ATEK, and they raised two needs. The first one was paperless, transparent requirements in the field of automotive as regards the retrospective monitoring of trainings and quality. The second requirement was to manage the production in a more efficient and cheaper way, and to have even more satisfied customer with more reliable deliveries and better quality. So in 2013, we started implementing a pilot project, and the customer could test our system, learned how it worked. It turned out that this was what the customer needed, and we continuously expanded this to other workplaces, including additional assembly workshops, EOL testers, packaging lines, retrospective traceability of the orders down to the level of the individual products. So in cooperation, we were able to modify the system and improve the system so that it could also include just-in-sequence functionality, which was essential for winning another tender for Rolls-Royce. And ATEC managed to win this contract, and they are successfully supplying to this automotive. So over 10 years that ATEC has been using our software, they found out that it's too tight, and they want to have another system in place.
2 years ago, it was renewed, and it was the operation was fluently connected. The system was enhanced, but our solution is as universal, as versatile and robust that we did not have to intervene in any way, and we just connected the new system and we keep operating. The customer also found that not only the monitoring of the data and the controlling of the production is not only thing which it is used for, but it is also used for other solutions for the overall efficiency of the staff in the company where the efficiency of the machine is measured, as well as the employee groups and their efficiency, their attendance, and the bonuses, monthly bonuses is system is connected with this. So this system is quite foolproof, and it is good to be followed. The second example I'd like to show is the company Cellier and Bellot. We know it as the producer of the ammunition for sports and hunting purposes. This company is subject to some demanding legislative requirements because of the products it produces. And 3 years or 4 years ago, they asked us they addressed us with a requirement for simplifying and simplifying the production because of, from the point of view of 100% traceability, which is required. They wanted us to monitor it and to keep it and document it if need be, so that we don't have to search for any papers, put them together, and pray that everything goes well, so that there is no gap. The second requirement was higher usage of the capacity of current machinery, because the production then already reached its limits when in terms of the capacity, because they had already run non-stop 7 days a week, and in order to the moments of getting some more, they didn't want to invest more into new machinery. They wanted to fully exploit what they already had. We implemented MES PHARIS at 18 workplaces in 2018, and it's not a long time, but within several years, the customer expanded the system to the remaining workplaces. At the moment, it is more than 120, where in addition to other things, they use the maintenance management, and they also use the data in the form of the reports and visualizations for online. at the daily level, the analysis of what has been done in the factory, where the problems are long-term and short-term, and they deal with them. So according to what they say themselves, I can't imagine that they should get back to the time when before the implementation of the system it would be impossible. They really appreciate getting rid of the papers, that they have a good online overview, and they have all necessary information available. They got rid of a lot of administrative work, and they can rely on the data. They can build analysis on them, and the data are credible. Tomáš has said here that the work doesn't finish with implementation. We continue with service support, service agreements. We are available on hotline at the on help desk. We help. We are able to expand help and we perceive the needs. We make our customers happy and satisfied. Of course, the production management is one thing, traceability or standards for the industry. This is all important, but it wouldn't be sufficient if we didn't use the data when the data are available. If they are available, if we look at the efficiency and the costs, we don't have to remind you of the overview of 8 types of losses. And today I would add another one, which is energy. The system provides you with the data to go with it, and it depends on the user what he or she wants to use. Our company, as I know it and perceive it, has a great added value, because in 15 and more years, when we do development and implementation of our own PHARIS system, we can provide our customers with the most suitable solutions how to implement internal processes. Not every customer has an opportunity to visit their competitors or other or different companies to learn and do things in a simpler way. We have this advantage. We have experience from many other customers. We are able to advise not only about implementing MES, but also about setting up the processes, production processes, if they were not optimal before then. This also concerns the continuous improvement processes. In my practice, I was also in charge of lean transformations, continuous improvement, transfers, startups, and I am able to advise not only regarding the data, but also how to set up some records of the time, what types of losses, what kinds of systems they need to have the greatest benefit from it. Thank you for this, and I'd like to pass the floor back. Thank you, Michael. I'll just add to it. In the morning, it was said that Industry 4.0 is a long-term process. We do perceive it this way, and we want to be the partner to the companies throughout the process. You need to start somehow. There are some alternatives, but it makes sense to us to start in a minimum alternative, but we don't limit any range of the functions. We want to be the partner for a long time. We want to come with more solutions. The current solution is very broad and comprehensive, and it's only the question how many needs the customer wants to deal with within the implementation and within the long-term cooperation with our specialists and consultants. I'd like to introduce also our partners program. We were mainly looking at implementation partners. Now we have come with a concept of resellers and business integration partners. We actively search for the companies with whom we have common customers, and we want to offer them a common value so that we only search somebody who wants to digitize and we would like to offer a comprehensive solution. It they don't have to be only the suppliers of the machines. They can be also the consulting companies, anybody who brings an added value to Industry 4.0. So it can be the business consultant, integration and implementation partners. These are the successful implementations. They are mainly the bigger companies, but the selection of the customers for whom we implemented the customer modifications, and from the know-how of which we draw for consultations, for feasibility studies that we do to potential customers. By this, I would like to say not goodbye, but I would like to invite you to our stand. I and my colleagues are at your disposal. We can meet and say what we can offer to you. Thank you. Have a nice day. Thank you for this presentation. We will proceed to the next point of the program. I'm quite curious about what Siemens, how Siemens does about the digitalization in brownfields and brownfield connectivity. I believe a lot of things can't agree on many things, but of course everybody says that it's much better to use the companies in the green belt, not the brownfields. But Siemens says that they have interesting solutions for the connectivity of the brownfields, and they introduced a new system of the connectivity in connection with the condition monitoring. Jaromír Vrkoč is the one who My name is Jaromír Vrkoč, and in Siemens I am in charge of implementing digitizing solutions, particularly for industrial companies. There are not many of us anymore. Hopefully some people are online, so greetings to them as well. And the topic of this presentation, I'd like to introduce to you the system, which is a new product. It's called Brownfield Connectivity, and it is a comprehensive solution of connecting the shop floor, that is the production machinery, with the upper IT layer. This solution is I'll get back to it. It is a basic cornerstone, and it is usable also for the companies which presented the MES systems and other systems. so they can integrate all this. In terms of information from production machinery, all the data, there is such a pyramid, you may know. The basic cornerstone is the data. This is the data. It is not the information. The information is the second layer. But the data is what we are able to collect from the control systems of the machinery. And this is what we use for acquiring information. The information then serves as a basis of knowledge, and then above that there is wisdom. What is important here? The main cornerstone contains the data, and if you don't have the bottom part valid, so it doesn't really matter how beautiful MES system is, how beautiful diagrams you have, it's good for nothing.
So I'm with the customers all the time. We are dealing with the implementation. And I encounter cases when the customers tell me, yes, we keep collecting the data, but it's quite strange. So there is no trust in the information. It's not well done. The information is not valid, and that's where we should work. And this brownfield connectivity system is something that has been implemented in those companies where they usually have some MES in place or some top tiers for the production management. The advantage of this solution is that it makes sense to implement it even with a single machine. So it's not something that pays off once you have 20 or more machines, so it starts at one. So now be more technical, but I would like to stick to the more general level. So I said that brownfield without reading data from the machine control system, this should be safe. The communication with the machine, if possible, this should be secured, so it should be encrypted. I dare say in 90% of cases this is not happening. What we see, it's not the case. The communication is not encrypted. Unfortunately, I witnessed two cyber attacks on large automotive companies in the Czech Republic, and it paralyzed completely half of the production. And this is something that should not be neglected. We've heard many times we read data and all that, but how do we do this? In 90% of the cases, I can guarantee you that it's not ciphered, it's not encrypted, the machine is open. You have boot-get communication, which is allowed, enabled, and someone who doesn't really understand how it works is still able to reprogram the control program of the machine and destroy the technology in a very easy way. Nothing difficult. So Siemens has come up with a brownfield connectivity product, and this takes care of the security of the data and the suitable way of communicating the data. So what we said at the beginning, this is a system which is good for the machining tools. So this diagram on the left side shows the control systems, Siemens, Sidomeric. These are control systems for machining tools. And here what stands out is the feature of the BFC system. So you have the machining tool and you can install a client, which is a small client application, and this small client application communicates via an internal bus bar with all the parts of the control system. So this is not only for Siemens Sinomeric, but Farnuk and other systems are supported, but I will talk about it later. This small client communicates with the NC part, where you have information about what is being produced, so information about the programs, overrides, and you name it. Then it can communicate with the drives. So this gives you information about the current drive load, temperature, position of the axis. So this is basic information for predictive maintenance. And it also communicates with the PLC part. And all the data is aggregated, collected, and then in an encrypted way, NQTT, which is a certified communication, the information is sent to a gateway, which is a Brownfield Connectivity gateway. This is where the data can be pre-processed. I will talk about it later. And then the data goes to all kinds of systems, to a database, local. We also support all kinds of databases, or it can also go to some cloud services. And of course, buffering is addressed. So once there is disconnection between the communication between the machine and the gateway, the data is buffered in the machine, and once the communication restored, all the data is sent to the system, to the database, so you don't lose the information. So we have some terminology, gateway, client, driver, but I don't think we need to talk about this. To make it reliable on the side of the machine, so that the data is buffered. If you lose communication, it's very important that the gateway or the center points through which all the data flows from the production machinery and also from some instruments, Centron, measuring instrumentation for energy monitoring. You have to make sure that the gateway is also reliable. So here we support something that you may know from other systems, the HR mode.
Tak se zapnem, super. A kde vlastně
So this is where the server part runs in parallel, and it can run 3-4 times. So once the main part fails, it gets reconnected to the redundant part, to the redundant cluster. And there is basically no downtime, no outage at all. So this slide shows a comprehensive view of what the Brownfield Connectivity system can communicate with. So this is the southbound, this is the shop floor screen, and where it goes to. So that's the northbound. So you see, I will talk about the details later on the next slide, but In fact, this comes from Siemens family. So here we have Sinumerix 840D power line solutions, 8 to 8D Sinumeric 1. These are new control systems for the machining tools. Now, if you buy a new machine, it will always be fitted with Sinumeric 1. But this is a way to the future. You don't have to be afraid. So they are newly supported. We have large frequency converters of all kinds of series, including GE120. We also support control systems of the third parties, which is FANUC systems, Heidenhain control systems, Beckhoff, Alan Bradley. So where can you store it? So the outputs, so these are basically database systems, Microsoft SQL, MySQL, all kinds of cloud services, InfluxDB, OPCUR outputs. So if you look at the details of the bottom part, so the BFC system, as I've said, Sinumeric, we have Heidenhain, FANUC, MT Connect, Modbus TCP devices. So these are quite often measuring instruments, compressed air meters, power consumption meters and things like that. Beckhoff, Omron. So these are the most interesting ones. So really the portfolio is large. Furthermore, we talk about the data extraction. So this is also about the data recording. So the system is able to carry out the registry in the control system in a safe way, and this feature can then be used in some MES applications where you tell the machine you are going to produce this, so choose this procedure, or you are not going to produce now because you've produced 5 defective pieces in a row. So this is just to give an example how this feature can be used. Furthermore, which is like an addition to this, which is comes automatically with the BFC system. You just need some additional setup. You have a central production program administration. So there are only 2 systems in place that can get directly to the NC active memory of the control system, and this is BFC system, and then the software solution Sinumeric Integrate I will show you later. But again, the production program administration, the communication is completely encrypted. So once you deal with the integration in large corporations where IT is really making sure, and they keep asking about the communication, whether it's encrypted or not. They don't want to permit you to do that. From the point of view of IT, there is no problem when you implement this BFC solution. So this was the bottom part, and now we will talk about where to send the data, what the system supports. So all kinds of cloud services that we provide, like our Amazon applications. So it's just a general cloud connector. And then, of course, if you have an on-premise solution, you have export to MySQL standard Microsoft SQL server, InfluxDB, you can use Kafka, OPCUA, MQTT, and WebDAV, and REST API, which is also usable for further integrations. So as regards rollout, this is quite simple. So you have a web interface, and in the first step you define the machine. So this is the source of data, client's data. So this is where you map out the machine, how you want to communicate. So you choose one of the protocols and you define the data you want to read or you want to enter. Then I can work on the logics with the data. So this is like the medium tier, and then it's in JavaScript. So let's say that I will give you an example. You have some simple operating condition of the machine. So let's say that the machine is in production. So this means that it doesn't mean that the information is included in the machine, but it is based on, let's say, 15, 20 conditions that need to be met. Only then I can say that the machine is really producing, and this is how I can enter the logics.
In this middle layer, middle tier. And so this is the gateway, this is the output, and here I can set up where I want the data to be sent. The most frequent implementation that we deal with is that the data is saved, as all data is saved, are saved locally into the local standard database server. And then part of the data are saved in some data services. I can look at BFC, whether the data comes from the machine. This is the view of the live data. And this is how the report looks of the production programs, where on your right-hand side you can see the workpiece of the directories for the workpieces, and the same is the production operator has it with him or her, and this is with the certificate, SSL certificate. So the work is very easy with this. Now we spoke a long time about this, about brownfield connectivity, where you can, if you look at the standard 4-layer model of the data, so down here there is a shop floor, here are some machines, and with the machines the brownfield connectivity communicates, so the data go up to the level of the application servers. And here, if you don't have any solution above that, so Siemens offers a possibility to use the condition monitoring system, which then is the nice pictures and all the things the person is working with. So we have the condition monitoring server, which works with the data, or you can use and send this data into the MES systems. And up here there is what the user sees and uses, and what we have seen here for the whole day. But the path is more complex, and there is a great emphasis on securing this. And this is how the final monitoring, condition monitoring looks. So this is the layout of the machine, the current fulfillment of the operational plan. These are the operational conditions, the analysis of the production for a certain period of time, the analysis of the production and of the scrap, the operational conditions in time and alarms. the alarm analysis, including the ranking of the most frequent ones and the ones with the longest duration. Here there are some aids, so all these are the data from BFC which we receive. It is only a form of visualization and processing and the prioritization of the alarms. The information about the machining tools, including corrections, including the length, average, and their changes. This is also very important in terms of the tooling machines, turning machines. Because if we have the correction, so the correction is 99% are set up manually, and this strongly affects the machine. This is the information from the drives. This is, for example, the load, the speed, temperature of the motor, etc. These data, we don't see much here, only that they correlate, but these data are necessary for further modules of predictive maintenance if you intend to have those, so they are very important. Siemens offers modules of predictive maintenance which work with this data, and the system then has an output which is the information to you that with a certain machine, with a certain axis, you have the remaining time of 3 weeks to solve the problem, and if you don't do it, the machine will stop. This is an example of some references. We are active in different automotive. This is Škoda, Hyundai, Continental, Doosan, Siemens, other plants of ours and other ones. The return in general is, we have done this for 7 years. This system is new, but in general, in terms of digitalization, I have been doing it 7 years, and the return on investment, because the customers have to calculate it, so it is the return of investment is from 4 months to a year and a half, depending on the scope of the implementation. So it is 4 to 18 months. That's all. If you wanted more information, we can talk about it. You have the data here. The email address jaromir.vrkoč@siemens.com. So you can contact me if you look at the Brownfield Connectivity. So you have also the website www.siemensanalyze.com. And so I recommend this, and that's all from me. Thank you. Thank you for this information about digitizing. We have proceeded to the last point of our agenda in this section, and we speak about digitalization, about the connectivity, and we definitely need fast internet. The 5G networks and their use for industry is the next topic of the presentation. So I would like to ask Ondřej Oubrecht from NTT Czech Republic to take the floor. So 5G networks and their use for in the industry from Ondřej Oubrecht from NTT, the Czech Republic. I recently received a press release that there is time for 6G networks. So maybe there is time to. Good afternoon. Welcome to the presentation where I will introduce basic information regarding private 5G networks, why they are used in industry, in what way they work, and what this network is. First of all, I'd like to introduce the NTT company. It is one of the biggest telecommunication operators worldwide. It owns a major part of the ocean optical networks, and it operates and 40% of the worldwide internet goes through NTT's network. It is an operator. It is a tier 1 operator, which means that most operators buy from NTT the interconnections for different other networks. I am an employee of the Czech branch. We are the network provider, and we also offer all the services of NTT. What is 5G private network and what they can bring to us? So these are the 5th generation networks, and private, it means that there is an operator of this network or the company which uses this. So the private 5G network in the Czech Republic can be run over your own site or on your own land if you buy licensed frequency. So it will be granted to you by CTU, and there are no legal disturbers, so the network should have the same availability, almost similar to the fixed connection. The network gives you a lot of advantages, such as low latency, which means that if you have autonomous systems, different conveyors, for example, which don't have the control system, but the control center is in the data center on the premises. So this machine has a lot of optical sensors, the radar, not to crash into anything, and these data are sent to the control center, and then they receive commands as to where the machine should be moving to. This is there is a slight delay of the signal, so that the transport is fluent, and the 5G networks have the low latency. They can penetrate the whole premises without wires, and the band should not be disturbed. For this case, it is to 99%, it is the best solution, and in 99% of the cases, it is implemented mainly for autonomous systems, mainly in the production, because the private 5G network you can imagine as a quality connection which you can access from each square meter of your hall or your site. Anywhere, if you build the network well, so everywhere there is the same quality of the connection, low latency and high speed. So this is one of the key reasons why in the production, logistics, and coverage of the site, the private 5G network is an ideal solution. I have a slide regarding the frequencies used. I believe you have heard that the television was used to be at the lowest level, 700 megahertz, where 5G private networks are implemented. This is the brand for mobile operators for public 5G networks. The band for private and public 5G network is between 3.5 to 4.9 gigahertz, where you can have some blocks of frequencies. In the Czech Republic, it is usually 3,400 to 4,800 megahertz, and this is the block where you can build your private 5G network. I'm often asked if I have the private 5G network, will it switch off the mobile networks over my site? So the answer is no. You can have all these networks can be present at the same time, and the 5G private network has no effect on the private O2 or T-Mobile networks, because they work on different frequencies, and they are supported by this.
So this is the band which is most frequently used, and this is where you can generate speeds about 1.5 up to 2 giga per second per cell, so which is multiple times higher than previously accessible. What is also getting prepared is 26 up to 35 gigahertz band. Here we say 28 gigahertz because it keeps changing, and the telecommunication authorities in the individual countries do not really know which band will be released for that. So these are high-speed transfers. So here you can get to 20 gigabytes. The coverage of a single cell is about 400 square meters. And of course, this band is like a radio connection, so this is like data connection with clear visibility. So the use is when you need really high data transfer speed. So this is also accessible, but it's 400 meters per meter. So if you cover any space, then you don't need to deal with the infrastructure. You have quality connection, which equals basically the landline in terms of quality. So why a private 5G network? What is their added value right now? So I've mentioned some of it. So I hope that it's really about the high-speed transfers, then the latency, which is mainly important for autonomous systems, which have control systems elsewhere. And I forgot to note that the control system in the data center for autonomous conveyors is here, because if the conveyor should have a server included or any computational machine inside, it's quite difficult to cool it and supply it with energy. So the service life would be 6 hours, and quite a lot of time would be spent charging the conveyor. So then it's the density of connection. So you can have about 1,000 times higher number of all kinds of sensors and other network clients who do not really cover the entire spectrum, but all these sensors that report data from the building or any other object. So you can connect this. Then, of course, you have more precise geolocation, so you can be more precise in seeing the position of the clients in the network. Of course, radio efficiency. Well, you have to believe me that it's there, because it would take one-day workshop to describe this in detail. And of course, the cell throughput, meaning that the throughput per cell. So this is just shortly how 5G differs from LTE. So 5G compared to 4G, they have a service-based architecture, more focusing on services. 4G are monolithic systems, so you have one packet code with its features. You cannot change anything, and basically everything has to be adjusted to the 4G network. With 5G network, you can have parts in the core where you have all kinds of computational mechanisms and things like that, and these deal with the specific tasks and things you need to address, compute through the network, and they can work independently of each other. So in fact, the spectrum can be divided into slices, which are specific segments, and they can also be above the radio spectrum. Of course, as regards the spectrum, there has been a major development in the Czech Republic for the private 5G network. We have a clearly defined spectrum defined by the authorities, and for the first time in the history, you can build up your own 5G network. So data throughput, of course, as regards the public network, it's also the distance coverage. Then definitely what is interesting is the modulation and what we call a multiple input, multiple output, which means that if you want to save energy and you have networks at various frequencies, then the equipment, your mobile phone or whatever, will transmit to the network at a lower frequency, which has lower energy demands, and receive at a higher frequency. So this can somehow save the battery life and ensure better throughput. And then, of course, much higher number of channels. So we, as NTT, we have our own manufacturers, so we also manufacture the technology for the private 5G networks. As part of the implementation, we can also supply 5G technologies from other manufacturers, so our technologies, Cisco, Nokia technologies, then of course radio part by AirSpan. We also have Microsoft in our portfolio. Some of our installations may be the most important ones, the Bonn airport, and now we are building an application in Frankfurt. In automotive, we also have some customers, so we do have a number of experience, and our delivery compared to mobile providers differs, because we submit the project not by just giving the customer the 5G network and do whatever and operate it however you like, but we can program the individual use cases of the 5G network. So if you take a decision and you want to have the 5G network for autonomous vehicles and you supply the it's only handed over once it's up and running. The same applies to the production line. For example, in the US, we built a production control for Schneider Electric. So you have a 5G network which controls the production line. As part of this technology, as we are a global telecommunication operator, if you have more sites and you want to cover them all with 5G network across the world or across the Czech Republic and cover it all, the network will behave as one. Of course, it will be interlinked. And if you need, for example, logistic company to follow containers outside your private network, then we can also supply our SIM cards that have roaming in all countries of the world, and they have two phone numbers through SSCA, and the phone number one is for the private network and the second number is for the public network. So still you can have the device connected at all times, although even if you cross the border. So here, this is just to show that the technology is quite simple. There is nothing complicated. So this is the packet core, which is the center packet core, then communicates with the system which is next to this, which is the radio network controller, BISBAN unit. Next to it, you have two radios, and then the antennas. Here we have the indoor access points, so it's similar to Wi-Fi AP, but this is just for 5G network. So if you are interested, of course, I'm available to describe the details. So this is the block connection, how easy it is to integrate it in the customer network. So here on the left, you see the radio network, including the individual client segments, then the packet core, then we have the customer network, one router, and the location register and the network control in a cloud solution. But as regards our solution, customer client data never leaves the client infrastructure, and the customer has all the network under its control, which is a major difference compared to the private 5G solutions offered by the operators, because they just get you one slice in their packet core, and you don't really know what's happening, and you cannot really control the network, because in fact it's still a public network, but you just take out a segment from the public network. So it's like a semi-private 5G. This is a full-fledged private 5G technology. So this is how easy it is to connect. So this is where you have the switch, some customer core, and here you can see the packet core, how it's connected to the baseband unit. So over the packet core, the edge compute means that you have the control system. It can be server, all kinds of installations. So this is something that then controls the autonomous vehicles, because you need low latency. So these systems can be connected to the packet core. So this makes you reduce the latency. Then you should use the data center switch, because it usually has very low latency as well. So this is just an example of slicing. So you have the individual network segments, and you can get your VAN, and it's over the radio part as well. As regards 5G, the difference is that you can use segments and use individual channels as segments, and get VAN and select connection, or do it logically using VAN. So this is the deployment. If you are interested in a proof concept, here you can see that you don't even have to drill. You don't have to install anything on the roof. You just put a column on, you add the antennas, and you get optical cables. And then what you get immediately is the radio on. It goes to the two antennas, so the radios do not have to be external. We also have indoor installations, and here what you see behind me is what the core looks like. So this is packet core, which can either be a standalone system, or you can have 3 appliance clusters. And we are able to cover the whole premises. On top of that, our technology, our entity private 5G technology, supports handover between Wi-Fi 6 and 5G networks. So if you have your own Wi-Fi 6, then you can connect handover. So the system fits in this box, all the equipment. You can deploy it quite easily, you can remove it quite easily. So this is the case of the proof of concept. Usually the project takes place in such a way that the client tells us what his idea is, what he wants to address through the 5G network. First we do the proof of concept, so we come to the customer and we integrate our network. The 5G network is deployed, and we can demonstrate the 5G network works in line with the security policy of the client. We can prove that the private 5G network meets all the security policies and requirements, that it's easy to integrate, that the deployment is not complex. And then we can demonstrate using the basic deployment all the facilities, all the features that are out there. And straight on, we can also deal with the final project the requirements, how to address it, what we need to apply, what needs to be programmed. And then the proof of concept, if it's successful and if we can agree, then it's transferred to the integration itself. So we built up the 5G private network. We help the client get him the license for the relevant bandwidths, frequencies, and then we hand over the entire project once all the user cases work. So thank you for your attention. If you have any questions. Thank you for your presentation. I think that the audience is tired to ask questions. So all I can say, if you have any questions, please contact Mr. Oubrecht directly. So thank you once again for your presentation. All that is left is to thank you for your attention that you paid to today's conference and to the digitalization section and the conference Industry 4.0. On behalf of the organizers, I would like to express my thanks to you for finding time and way to be with us today, either here in the hall or online streams or records. I believe that the conference has been inspiring, and I hope that next year we will hopefully meet again. So once again, thank you very much. That's it for today. You can definitely stay for some networking events and exchange of experience, but this part is over. Thank you once again.